So we learned that when we evaluate limit, we have three approaches to take. Number one, direct substitution. Number two, factoring. And number three, multiply the top and bottom by the conjugate if we have a radical expression. Now take a look at this limit. If we do our first approach, direct substitution, we see that the numerator is x minus 1, 1 minus 1, 0. So we cannot do direct substitution in this case, and it doesn't seem that we can factor or do a conjugate. So we have to transform this complex fraction before we can apply our number 2 or number 3 method. We never want to deal with complex fraction. So we take a look, we have a fraction inside a fraction. We will multiply the top and bottom by the smallest fractions denominator, which is x plus 1. If we multiply the top and bottom by x plus 1, we will get rid of complex fraction. So in this case, we get limit as x approach the number 1. On the top, we get 1 over x plus 1 times x plus 1, you get 1, minus 2 times x plus 1. In the bottom, we get x squared minus 1. So now we take a look at the top. So we simplify. We get 1 minus 2x. Minus 2 goes into x, right? And then minus 2 go into 1, minus 2. Okay, x squared minus 1. Now we continue, we get limit as x goes to 1. On the top, we get negative 2x minus 1. In the bottom, we get x squared minus 1. Can we do the factoring? Yes, we can. Limit as x goes to 1, x minus 1, x plus 1. So on the bottom, we get minus 2x. Or on the top, we get minus 2x minus 1. Any cancellation? No. So now what do? Because we cannot factor anymore, we cannot do conjugate anymore, and we cannot do direct substitution because we have a 0 right here when we plug in x equals 1. So then, when all three techniques fail and we try everything else, so we might go back to our estimate. Okay, so we either look at the graph or we look at the table. So if you plug in the number x equals 0.999 or the number x equals 1.0001, you realize this function, this expression, doesn't approach one single number. So you can already say this limit does not exist. Okay, so when we fail all three approach and when we use a graph and table to confirm that there's no limit, then we can say the limit does not exist.